In an isosceles triangle, the base is 16 and a side is 10. Find the radii of the inscribed and circumscribed circles and the distance between their centers. Solution. Let's consider an isosceles triangle, ABC. AC is the base, measuring 16. The equal sides AB and BC both measure 10. To find the radii of the inscribed and circumscribed circles, we need the area of this triangle, as area is a key component in the formulas for both radii. The formula for the area of a triangle is 1/2 times the base times the height. We know the base AC is 16, so we need to find the height. We draw the altitude BD from vertex B to the base AC. Since it's an isosceles triangle, this altitude also bisects the base. So AD is half of AC, which is 8. We can find the length of the altitude BD using the Pythagorean theorem in the right-angled triangle ADB. The theorem states BD equals the square root of AB squared minus AD squared. Substituting AB as 10 and AD as 8, we find the altitude BD equals 6. Now we can calculate the area of triangle ABC. Using the formula 1/2 times base AC times height BD, and substituting AC as 16 and BD as 6, the area of the triangle is 48. Next, we find the radius of the circumscribed circle, R, and the inscribed circle, R. For the circumscribed circle, the radius r is found using the formula r equals AB multiplied by BC multiplied by AC, all divided by 4 times the area, S. Substituting the side lengths 10, 10, and 16, and the area as 48, we find that r equals 25/3. For the inscribed circle, the radius r is found using the formula r equals the area S divided by the semi-perimeter P. First, we calculate the semi-perimeter. The perimeter of the triangle is 10 plus 10 plus 16, which is 36. The semi-perimeter P is half of that, so 18. Substituting the area 48 and the semi-perimeter 18, we find that r equals 8/3. Finally, we determine the distance between the centers of the inscribed and circumscribed circles. In an isosceles triangle, the incenter, the center of the inscribed circle, lies on the angle bisector of the vertex angle, and the circumcenter, the center of the circumscribed circle, lies on the perpendicular bisectors of the sides. In this type of triangle, the altitude from the vertex to the base also serves as the axis of symmetry. It is simultaneously the angle bisector of the vertex angle and the perpendicular bisector of the base. Therefore, both centers lie along this same altitude from the top vertex to the base. The length of this altitude, segment BD, is 6 centimeters. The incenter is located R, which is 8/3 above the base AC. The circumcenter is located R, which is 25/3 from the top vertex B. Therefore, the distance between them is given by the formula R plus R minus height. Substituting r as 25/3, r as 8/3, and the height as 6, the distance equals 5. Answer: the radius of the inscribed circle is 8/3. The radius of the circumscribed circle is 25/3, and the distance between their centers is 5.